Okay, hello guys. My name is the librarian, and I'm here to discuss with you the extraction of iron from its ores. Ores, what we call the ores. Let me write here. Ores. These are just mixtures of substances. It has impurities in them. For example, if you have something like this, you have iron. Maybe you have silicon that is occurring as a clump eh? I think yani inaokaa kama kitu ambayo imeshikana, so kumaanisha we must first to break it into small pieces so that we can separate the iron and silicon, but still we have to learn it in a furnace. Yeah, this something, this shell or this something that where we are putting our mixture is what's called the furnace. Then because we are forcing air to enter into this funnel, that's why we call it the blast furnace. The blast furnace, meaning we are forcing air to enter into it. And remember, what do we require? We have these iron ores, and iron ores may be iron 2 oxide or iron 3 tetra oxide. Those are what we usually use. And iron 2 oxide, yeah, iron 2 oxide is what we call hematite. We call hematite, and iron 3 tetraoxide is what we call magnetite. And we have other ores. We have other ores such as iron pyrites. Iron pyrites, what we call the phase 2. Yeah, we have others like what we call siderite, what we call the iron carbonate. Yeah, and with those, and then we go down here. So those are the ores. We use coke. Coke is just carbon, which in solid form. Then we have calcium carbonate. Coke is used as a reducing agent, and limestone will be used as a substance that is used to remove impurities, and we shall see how it removes those impurities. Now, in this furnace, remember what I said, we are forcing hot air to enter into this furnace. That means hot air, it has oxygen in it. It has something we call oxygen gas. And coke, remember we said these are solid substance. So when we inject them, they start moving down. We shall find that our carbon will react with oxygen. So our first reaction at the base of this furnace will be carbon plus oxygen, and this one will give us carbon 4 oxide as a gas, right? Then the carbon that is still moving, remember you are continuing adding it, then we shall find that the carbon will react again with the gas that is being produced, because the gas being produced inaanza coalesce above the furnace. This is a gas that will come out of the as hot air, zitatokea huko. So carbon ita react with carbon 4 oxide yenye itatupatia carbon 2 oxide. Now remember our iron yenye tulisema tunatumia is the magnetite, the hematite. We are using hematite as our iron ore, that is F2O3. Remember now this one still bado tunaiadd these things. This is a mixture that we are adding. That means coke tumeona vile inaendelea, vile mambo yake vile inafanyika, then tushaona sasa tunataka kuona iron ore, hii hematite vile itaendelea kufanyika. Ikiteremka itakuja kureact na our carbon 4 oxide. Carbon 4 oxide ukiweza kubuka pale kwa carbon and this compound inatumika kama reducing agent, so inamaanisha ita reduce our iron 2 oxide to iron and carbon 4 oxide gas. Exactly. Now, after now this reaction has occurred, yeah, now we have our ion, yeah, now it will come and settle here. And remember, because remember what I said, we already broken this one, this all too small. So our ion has already been separated. Now we have our ion, and now other impurities are now coming. And remember our limestone, yeah? Limestone tulisema itatumika kutoa impurities, kumaanisha tukiweka hapa limestone, remember this changes in temperature kuna zina increase, kumaanisha calcium carbonate it will be acted upon by heat and will decompose, kumaanisha kidecompose to form calcium oxide plus CO2, right? This CO2 is the one which is reacting with carbon to form carbon 2 oxide. Then carbon 2 oxide ina react na iron 2 oxide to form iron. Now the iron that yenye tulifanya inakuja ina settle hapa chini, and because the other impurities are going to react with calcium oxide, right? Impurities that are found in iron, and this one occurs naturally, is such as silicon. So silicon ikireact na calcium oxide itatupea calcium silicate. This one is what will come out here. This is our slag. We call it slag, yeah? Or hot impurity, which is calcium silicate oxide. So inamaanisha, and because calcium oxide is less denser, yeah? Is less denser than iron will settle here, then calcium silicate oxide itasettle hapa. So kumaanisha slag itatoka hapa, then our iron itatokea huku chini. Sasa maswali mingi itakuja kukuuliza namna gani? Maswali mingi itakuuliza ni which impurity ilitokeanga hapa, and then write the equation. So kitu unafaa ujue, kwa iron tuko na impurities such as silicon, and then silicon will react with calcium oxide. Remember calcium oxide imetoka kwa calcium carbonate after isha decompose, right? So ita react na calcium oxide form calcium silicate. Then wanaweza kuuliza swali kama useme the function of limestone ama calcium carbonate, yeah, it is to remove impurities. Tunaona inakuja ina react na silicon which has impurity, ikisha react na impurity inaitoa, inawezesha kuitoa because inaifanya ikue less denser, so therefore ina float huku chini. Huku juu inaweza tokea kama slag, pia huku bado itakuja kama slag, as bado hii ni slag but this is pure iron. Then other hot gases such as carbon 4 and carbon 2 oxide hizo nazo zinapotea, na hii extraction of iron is as simple as that. And have a nice time and enjoy your reading. And hizi equation utakuja tu kuzibalance. Kama hujui kubalance equation, tafuta video ingine kwenye hii channel yangu.